Hey everyone, thanks for joining. My name is Deeran, and as a CSE 237D student, I worked with the Radio Telemetry Tracking Group this quarter, an ongoing Engineers for Exploration project. Let me share a bit about it with you. Researchers tag and release animals to learn about their environment and movement patterns. Ideally, researchers would like an application that allows them to search for one of those animals. The result should be an X marks the spot with the animal's current location. Unfortunately, reality is kind of a jerk, and there are several issues that we have to deal with. These include the fact that the animals we want to track can be quite small, and the manual tracking process involves lugging around bulky equipment while maneuvering difficult terrain. The radio telemetry team introduced drones to solve these problems. By attaching sensors to the drone, we can optimize the drone's flight path based on the detected pings. Since we can now control the hardware via software, we can check for pings much more frequently and can even track more than one tag at a time. This approach brings us pretty close to the ideal we wanted. So how does this actually work? This piece on the bottom is called the User Interface Board, or UI board. Its job is to read data from the drone sensors and send it to the onboard computer, or OBC. The OBC corresponds the data with pings received from the radio and forwards it to the relevant algorithms. Finally, the OBC uses this information to send heartbeats containing the drone status to both the UI board and a third component called the Ground Control System, or GCS. The GCS is essentially a laptop located with the researchers on the ground that allows them to view the drone's progress in real time. So what work did I do this quarter? I dusted off an old simulator the team had built and updated it to satisfy the drone's current requirements and APIs. The simulator emulates data packets sent from the UI board, as well as the heartbeats sent by the OBC, and uses FIFO pipes to simulate the serial communication channels on the actual drone. Given the current remote environment, this allowed the team to continue working on the project even without physical access to the drone. Even once the team is in person again, the simulator will reduce the need to timeshare access to the single physical drone. The functionality to send data from the UI board to the OBC already existed, so next we implemented the OBC's ability to receive the data. I worked with another team member to implement the logic to receive the data packets via a serial channel and parse them. With this working, the information can now be combined with the pings to get location estimations. While the UI board worked within the simulator, we also needed to ensure that it works on the drone as well. To do this, I deployed the software onto the physical drone to see what would happen. That's okay, that was just beginner's luck. Day 2 will be better. Huh. Well, third time's the charm? I am very happy to report that the software now runs on the actual hardware with no issues. A seamless process as expected. And now, the moment we've all been waiting for, live footage of the drone in operation.
Due to an ongoing pandemic and the fact that I've located several hundred miles away from the drone, I do not have any live footage of the drone I can share. I apologize for any undue excitement this may have caused. Thank you.
Sorry for that little teaser there. While I was unfortunately not able to see the drone in action, the team's goal is to have it ready by the end of the summer for in-person testing in a partnership with the San Diego Zoo. Best of luck to the team, and thank you all for listening.